Hi friends, welcome back. Today we will see predict the type of breast cancer using SVM. So in the last video we have seen the same problem statement with different algorithm of supervised learning. So you can check out all that videos, and this time we will do that with SVM. So yeah, again let's get started. So first, importing the necessary libraries. All the stuff is same as we have done. Importing the data file. Yeah, again I'll also provide, although I have already provided this CSV, but I'll also provide this in the description also. So after importing the file, you can see that the columns that we have are ID, column thickness, cell size, cell shape, marginal addition, so single epithelial cell size, right? So all these are attribute of the cancers. Okay, cancer report. Now the dataset.info, so all these the column that we have, all we do not have any null values, right? Each values are of integer type except bare nuclei, right? Now let's get the description on the basis of transpose or all the columns. So you can see that this is the description of the data set that we have. Now let's impute or replace the null or unuseful value. So what we are doing is, first we are checking for the this symbol, right? So if it is exist, just replace that with none values in our data set. Secondly, we are applying one lambda function to fill NA. So NA will be filled this time by the median, okay, median of our data set or the X. Now converting the HP column from object bare nuclei string type to float type. So how will you do that? We will just write the S type. So this is the data type that we want to convert, right? And this is the data column that we want to convert. This is again we will contain it as float 64. So this time you can see that if we get the is null dot sum value, so there are no null values, right? So now we are printing the pair plot, passing the data set, diagonal kind is equal to KD, U equals to class. So you can see that these are the pair plots for each values. Now from sklearn.model selection, importing train test split, so to calculate the accuracy score of the model. So now from sklearn.matrix, importing accuracy score and confusion matrix. Target equals to our data set of class, feature equals to our data set dot drop ID class, that is xs1, xtrain xtest ytrain ytest, that will be train test split. We are passing features, target, test size, where test size is 20%, that means 70% will be our train size. Random state, we are passing it to keep the values as same. Now from sklearn.svm, import SVC. So we are initializing our model, that is SVM, and building a support vector machine on train data. So how will you do that? SVC model will be SVC C, we are passing 0.1, kernel is linear, gamma is 1. So all these values that needed to be passed in SVC, so we are defining them. SVC model dot fit, that will be xtrain ytrain, right? And prediction, that is our SVC model dot predict xtest. So this way you will get the prediction here, and if you check the model score of xtrain ytrain and xtest ytest, so you can see that the model score for xtrain ytrain is 97%, and for xtest ytest or our testing data set, it is 96%. Let's print the confusion matrix. So the confusion matrix is based on this prediction that we have and the y-test. So you can see that this is what we got. Now building the support vector machine on train data. Now same thing we will do for train data. This time the SBC, we are setting the kernel as RBF. So RBF is nothing but radial basis function centered to each point, right? So this way we define that. Now SBC model, we are fitting the model on the train data, xtrain ytrain. So this is now model is generated. So now we are getting the score of again xtest and ytest. So we are passing xtrain ytrain, xtest ytest. So you can see that this time it is 99% of the xtrain or ytrain, and 95% of the X test, Y test. Now building a support vector machine on trained data, changing the kernel. So SVC model is our SVC, kernel equals to poly, SVC model dot fit X train Y train, right? Prediction will be our SVC model dot predict X test, and now printing SVC model dot score, that will be X train and Y train, and printing SVC model dot score, that is X test and Y test. So here you can see that. Next thing we have is SVC model, right? We are defining this model as sigmoid function, sigmoid model. This time, last time we have done with poly, this time it's sigmoid, to differentiate basically the prediction that we get or the model score. So doing the same thing, prediction than the score. So this time you can see that the train score is 34% and the test score is the 32%. So now hope you have hands-on with this as well, and just write the code, and if you have any problem, please do let us know. Also compare your code with the other algorithm that we have already done. Okay, so then you can get the idea or a better idea that what you have observed here. So yeah friend, this was all about today. If you like the video, please do share, subscribe and like. If not, please dislike and let us know where is the problem that you have found. Thanks, and let's meet in the next video.